Pluto is a distant and stealthy, more unpretentious planet that was once a part of our nearby planetary system. However, advancing and disturbing announcements by leading astrophysicists Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight. They propose that this chilly world is on a potential collision course with Neptune. But how could this really work, and what might be the results of such an enormous event? Are we seeing a bewildering huge erraticism, or is there something else to this looming setback? Join us as we examine the potential results of a Pluto-Neptune impact. Pluto, a former planet that was reclassified as a dwarf planet, remains a subject of interest and study in the vast universe. As shown by recent theories from leading specialists, Pluto's orbit is perilously close to Neptune's. Astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising the alarm about a potentially hazardous collision between these two planets, which could represent a massive risk to Earth. But how is such an event even possible? Pluto's trip around the Sun is unlike that of any other planet in our solar system. It requires a dazzling 248 years to complete a single orbit, and since its discovery in 1930, it hasn't even finished one full revolution. At any rate, the intrigue doesn't stop there. Pluto's orbit is marked by its particularly elliptical shape, wandering widely from the almost circular orbits of the major planets. What makes Pluto's orbit even more surprising is its inclination, which is 17 degrees to the ecliptic plane. The way Pluto follows its path is significantly more irregular compared to other planets. This tendency and unpredictability add layers of complexity to its orbital arrangement. Potentially one of the most intriguing parts of Pluto's orbit is its intersection with Neptune's. For about 20 years in each orbit, Pluto actually moves closer to the Sun than Neptune, defying expectations about their positions in the planetary system. This prompts the usual question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational effects of other planets. The examination of Pluto's orbit began shortly after its discovery. Initially, astronomers attempted to figure out its unique path. Unlike other planets whose orbits lie fairly close to the ecliptic plane, Pluto's orbit stands out with its steep inclination and erratic shape. The mystery grew with the realization that Pluto's orbit does indeed cross Neptune's. The stability of Pluto's orbit, despite these intricacies, is evidence of the complexities of celestial mechanics. The three-body problem in space involves determining how three objects like Pluto, Neptune, and the Sun move and influence each other with their gravity. It's like trying to predict where they will go based on where they started and how they pull on one another. In Pluto's case, this problem shows how its orbit, Neptune's orbit, and the Sun's gravity all work together in a complex way. The terms non-concurrent libration, orbital precession, and VZK wobbling are key to this puzzle, as explained by astrophysicists. What keeps all planets in their orbits is non-concurrent libration. Regarding Pluto and Neptune, this term essentially means that when Pluto crosses Neptune's orbit, it is positioned no less than 90 degrees away from Neptune. This spatial division is critical in preventing their orbits from meeting. Orbital precession, on the other hand, refers to the vertical movement of a body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other giant planet, it is positioned far above their orbital plane, adding an extra layer of protection from potential impacts. Another key factor in this situation is VZK wobbling, named after three researchers, Veselov, Zeldovic, and Kai, who studied how objects move in space. It involves how three space objects like Pluto, Neptune, and the Sun pull on each other with their gravity. This pulling influences how they move. In Pluto's case, the VZK wobbling helps us understand why its orbit close to the Sun is so unusual. Despite Pluto's orbit appearing chaotic, this wobbling helps keep it moving smoothly over extended periods. VZK wobbling shows that although things in space seem wild and unpredictable, patterns and rules maintain some control. These forces help keep Pluto's orbit stable, ensuring that it doesn't collide with Neptune or drift off course. This three-body problem is crucial in understanding how these orbits change due to the way space objects pull on each other. Studying this helps us learn more about Pluto, our solar system, and even distant worlds and their stars. Numerical simulations in the late 1980s revealed that despite the stabilizing properties, Pluto's orbit is actually erratic with minor deviations in initial conditions, leading to huge differences over centuries. However, these peculiarities of Pluto's orbit have been found to maintain stability over extremely long timescales. Checking the disruption from later automated examinations has helped us understand how the giant planets like Neptune, Jupiter, and Saturn affect Pluto's orbit around the Sun. Neptune has a special relationship with Pluto, where for every 2 orbits Pluto completes around the Sun, Neptune completes 3. This relationship helps keep Pluto's orbit stable. However, Neptune isn't the only one at work. Jupiter's gravity also plays a colossal role in stabilizing Pluto's orbit, and Saturn contributes as well. These studies show that Jupiter's massive gravity is strong enough to ensure Pluto stays on a steady path for a long time, potentially even for millions of years. So perhaps Neptune, Jupiter, and Saturn are cooperating to ensure Pluto continues to move safely through space without running into trouble. These idiosyncrasies are key to keeping everything in place and safe in space. Without these mechanisms, the solar system, as we know it, would be a much more violent place. Bodies like Pluto could collide with others or be ejected from their stable orbits, triggering a chain reaction with other celestial bodies. For Pluto, especially with discussions about it potentially colliding with Neptune in the future, understanding its orbit is crucial. This gives a clearer picture of the dynamic nature of the planetary system. The case of Pluto shows how even the most seemingly unstable orbits can reach a state of balance through the complex interaction of gravitational forces and orbital mechanics. It also underscores the importance of constant observation and study of these phenomena to better understand our place in the universe. Exploring the depths of space often leads us to confront the strange nature of celestial bodies, and Pluto's orbit is an ideal example of this irregularity. The concept of orbital chaos, which refers to the fragile dependence of a celestial body's orbit on its initial conditions, is clearly demonstrated in Pluto's case. This means that even slight changes in the dwarf planet's position or speed can dramatically alter its long-term orbit. Using automated simulations has been hugely helpful for scientists in figuring out how Pluto moves in space. These simulations use complex mathematics to model how Pluto and other space objects like Neptune pull on each other. By tweaking small details in the simulation, space researchers can see how even minuscule changes can make a huge difference in where Pluto ends up. In the late 1980s, these simulations showed something interesting about Pluto's orbit. Despite having features like asynchronous libration and orbital precession to keep it stable, its orbit can still be inconsistent and unusual. If you start with just a small difference in where Pluto is or how fast it's moving, its orbit could end up looking completely different after just a few years. Yet despite this chaos, Pluto's orbit remains stable over vast timescales like billions of years. This means that Pluto's journey around the Sun has a kind of order to it, even though it appears wild at first. Predicting celestial movements, especially when they involve irregular orbits like Pluto's, is a massive challenge. The inherent unpredictability of these systems means that long-term forecasts are often filled with uncertainties. While numerical models provide excellent tools for understanding and predicting the future movements of celestial bodies, they also highlight the limits of our predictive abilities. These models heavily depend on the accuracy of initial conditions, and any small mistake or distortion can lead to vastly different outcomes, making precise predictions a daunting task. Beyond the chaotic nature of planetary orbits, Pluto reminds us of the ever-changing and dynamic nature of the universe. While we've made huge strides in understanding space, Pluto's case reminds us of how much of the universe still remains a mystery. Grasping the gravitational effects of the giant planets on Pluto's orbit provides valuable insights into the broader dynamics of the solar system. It shows how the presence and position of each planet can significantly affect the stability and course of other bodies within the system. So why are leading astrophysicists recently raising concerns about a potential collision between Pluto and Neptune despite all these complex forces trying to prevent such an event from happening? Neil deGrasse Tyson, a prominent astrophysicist and a major figure in advancing cosmology, offers a unique perspective on the mysteries of our solar system, especially the intriguing case of Pluto. Tyson, known for his role in renaming Pluto from a planet to a dwarf planet, offers insightful analysis on the evolving nature of celestial mechanics and the public's interest in the neglected corners of space. Tyson's position on Pluto's renaming is based on the ever-expanding knowledge of our solar system. He sees the renaming not as a diminishment, but as a necessary adjustment to our growing understanding of the various bodies orbiting our Sun. Tyson's approach to celestial mechanics is one of continuous learning and change. He sees the complexities of orbits like Pluto's as a sign of how much there is still to discover in space. This curiosity keeps the study of space so exciting. However, despite Tyson's optimism, his thoughts on Pluto's potential collision with Neptune paint a more serious picture. His concerns about the fate of Pluto's orbit suggest that we may still have some mysteries to uncover. Will Pluto crash into Neptune, or is this just another moment of confusion in the ever-changing universe of space? Only time and further investigation will tell. For now, we are left with a deeper curiosity about how little we still know about our own solar system. We continue to study these celestial phenomena with the goal of uncovering more of the secrets that lie beyond. The possibility of a Pluto-Neptune collision raises questions about the mysterious and captivating universe in which we exist. The potential for a mishap between Pluto and Neptune challenges our traditional understanding of planetary stability. The idea that two celestial bodies with such vastly different attributes could collide is both unsettling and fascinating. Given that Pluto is situated in the outer reaches of the solar system far from the major planets, and Neptune is itself a gas giant with a strong gravitational field, the implications of such a collision would be enormous for our understanding of gravitational interactions and the evolution of the solar system. To understand the dynamics of a potential impact, one must first consider the structure and properties of the two planets. Pluto, despite being a dwarf planet, contains a variety of elements and compounds believed to exist in a frozen state due to the extreme cold of the outer solar system. Its surface is covered in nitrogen ice, and it has an atmosphere composed mainly of nitrogen, methane, and carbon monoxide. In contrast, Neptune, a giant gas planet, is composed mostly of hydrogen, helium, and other lighter elements with a deep, dense atmosphere. A collision between such disparate bodies would dramatically affect their structure and behavior, potentially creating an event noticeable across vast cosmic distances. What makes this hypothetical collision particularly intriguing is the impact on other planets and bodies in the solar system. While Neptune's gravity plays a dominant role in keeping Pluto's orbit stable, it is not the only factor at play. The presence of Jupiter, the most massive planet in the solar system, is another crucial factor. Jupiter's enormous mass, strong gravitational field, and gravitational influence provide a stabilizing effect on Pluto's orbit, preventing it from wandering too far into Neptune's territory. Moreover, Saturn's gravitational influence further complicates the dynamics of the outer solar system, making it even less likely that a devastating event will occur between Pluto and Neptune. However, despite these safeguards, ongoing research shows that the relationship between Pluto and Neptune is not as simple as a clear collision course.